this session about upcoming facilities that can be used for LSST follow-up. So the first talk will be given by Paolo D'Avanzo about SOXS, the transient hunter.
It works, okay. Thanks a lot. Good morning, everybody. Thanks a lot for being here, and thanks a lot to the organizers for giving me and to the SOXS project team the opportunity to provide what I'm going to do now, that is an overview of the status of the SOXS instrument, SOXS, that the son of a shooter, that will be the new spectrograph that is going to be in operation at the ESO NTT telescope. So let's do a recap of the history. There has been an ESO call for new instruments at the NTT in mid-2014, and we did a proposal, the SOXS. The PI of SOXS is Sergio Campana from the Brera Observatory in Italy, INAF, and the submission early 2015, and SOXS has been selected by ESO. 19 proposal, we have been selected in May 2015. So a big achievement. We are all very happy. So memorandum of understanding and everything. We need there was a need of 1 year before really starting working on the SOXS project from our side. And here you can see all the steps. So the preliminary design, it took 1 year, achieved. The final design took a bit more than 1 year, achieved, and now we are in the real work part. No, sorry, the hardest part of the work, that is the manufacturing, assembling, integration, and testing that is still ongoing, reaching to the end of this project. You can see it took more than 5 years, including the pandemic time. So, as I told you, the beginning of the operation for the procedure for the preliminary acceptance in Europe by ESO, that is constantly reviewing our progresses, providing us a lot of useful inputs, should start by end of April, beginning of May, and last for 3 months. Then it will be time for packing and shipping to Chile, everything, where in end of summer is foreseen the period for commissioning, science verification, preliminary acceptance in Chile, and it is foreseen to take 6 months of activities. So that starting from early 2025, for 5 years, we should have our operations and guaranteed time observations. So this slide, I provide all you need to know, the basic information you need to know about SOXS. As I told you, the instrument has been built for being mounted. It will be mounted at the ESO NTT. It will be a single object slit spectrograph. It will be a broadband, more or less like a shooter, so from 350 to 2000 nanometers. The resolution will be around 4,000, 5,000. It will have 2 arms, the UV and visible and the near-infrared arm. You can see there the wavelength range. There is an overlap between the 2 arms. And it will have an imaging and acquisition camera with all the, basically the SDSS-LSST filters. This will be the field of view, the pixel size. Sorry, here is not reported. Later, we also have the V-band filter. You can see here the design, and here the real instrument that is now in Padova, the INAF Observatory of Padova in Italy, mounted at the ESO NTT simulator. So this is the consortium. There are contributions from 6 countries. The consortium is led by INAF. So here you see Israel, UK, Chile, Finland, and Denmark. And here the relative contribution to the whole project, as I told you, you see INAF is the main partner, and then all the contributions, and also the duty, what each institute is in charge for. Here another view. Basically, you can see here the key relevant people. So we have the principal investigator, Sergio Campana, the project manager, Pietro Schipani, the system engineer, Riccardo Claudi. There is me, responsible for the science, the instrument scientists, all the work package managers, and there is a science board. You see here, driving all the science needs of SOXS, and that will be in charge also for the GTO and so on. And here you can see the people involved there. And here another nicer view. There are the names of all the work package responsible people. This picture has been taken as the Padova Observatory at our last progress meeting. So here in this picture you see all the relevant people named there, plus other people that is working at the project in the various work packages, and our friends from ESO visiting us for the review. And now let's go a bit into the technical details, presenting the instrument. So this is the UV and visible arm. As you can see, at variance with the shooter, here we have at the top right 4 straight parallel spectral orders, okay, U, G, R, and I. And you can see there, bottom left, this is the efficiency, the total efficiency, taking into account everything, telescope, instrument, atmosphere, everything. So you can see that it's pretty good, it's pretty high, going close to 30%. And here, the last plot is the resolution per arm, the expected resolution per arm going from 3,500 to highest values. And here it is a real spectrum. Okay, so as you see, the instrument is mounted, so is being fed by the telescope simulator and by the calibration box. And so the expected, and here it is a real spectrum of a calibration wavelength, an arc lamp, basically. Okay, let's go to the near infrared. Of course, here we are working in vacuum, cryogenics, and so on. And here it is much more similar to a shooter. If you are probably users of a shooter. So here the orders are curved. Okay, the spectral orders. Here again you see the efficiency, which is pretty good, not as good as the UVVs, but still pretty good. Again, including everything, also the atmosphere, and again as before. Now you know the resolution. Lambda over delta lambda per each spectral order. And again, here we have real spectra taken in the lab, of course, with the instrument mounted. Here you see again a calibration wavelength lamp at the top and down, and through a 1 arc second slit. And if you go down, the plot down shows you the snapshot, the same as above, but taken through a multi-pinhole mask. It is useful then for the pipeline, wavelength solution, and so on. We also have the acquisition camera that is not just an acquisition camera, but is also a very good imaging camera. So SOXS will do also imaging, also photometry. So as I told you, the camera is the curve there with the arrow is the efficiency of the CCD among the many of the Andor vendors. So that is our one. And here you see, as I told you, we have the same LSST filters, including the Y band, and we also added the V filters. And here you have the typical limiting magnitude for signal to noise ratio of 10 for the typical exposure, for example, of a quick acquisition. And of course, we are in charge of setting up a pipeline. We will need the pipeline since day 0, of course, and of operation. A proto pipeline is already available for our test. We are intensively testing. It is still able to do the order tracing and the wavelength solution, the sky subtraction, and so on. Anyway, in the end, it will be able to do everything. So it will produce you the reduce, bidimensional and one-dimensional spectra, flux and wavelength calibrated. You can, if you want, you can perform your own custom extraction of the bidimensional rectified spectrum if you prefer, if you have your own scripts. Otherwise, the pipeline will do everything. And it will follow the ESO standards, and it will be integrated in the ESO reflex workspace and so on. And it will have also the capability of working on photometric data, okay? And the pipeline, of course, will be public. The idea is to have something that is working automatically, continuously in near real time of all the data that are produced by SOXS. Then, of course, it will be possible to perform custom reduction, so step by step, if you prefer to check everything, and of course, through the intermediate products and so on, but you know this thing. So let's go to the GTO time. The consortium will be rewarded by 189 nights per year, so 50% of the NTT time for 5 years. So doing some computation, average the night duration, efficiency, and so on, bad weather, about 1,000 hours per year. And the GTO SOXS has been built for transients, for the time domain astronomy. So the GTO observation will be basically, if not all, target of opportunity observations of transients. Okay, so the SOXS consortium will provide clear triggering criteria, okay, for which will be the sources that will fall under the umbrella of the GTO. The data, the usual ESO policy, 12 months proprietary of private time. And there will be also a significant fraction of the GTO time, around 25%, dedicated to classification. So new transients to be spectrally classified. Okay. Then let's go to the operations. So this is a very important and complicated part because basically it will be a dynamic schedule. The 6 months, 50%, the 180 nights are not fixed. Can be the time of the consortium can be taken at any time. The most important thing is that at the end of the semester, there is the right balance between GTO time and ESO time. This is to guarantee that when an interest in transient is there, we can go on it and not wait for the night where the GTO time is scheduled. So there will be a dynamic schedule that will be done on day by day, night by night, day by day basis. Okay, and of course there will be SOX scientists that will be on call in case of problems. We hope there will be not, and you will see in the next slide also for unforeseen targets, transients, sorry, exploding, going out during the Chilean night, so that were not there at the time of the submission of the night schedule. So the idea that there will be after the initial period of assessing everything, there will be no SOX scientists on the mountain. So the operations on the mountain will be carried out by the telescope operator that will have a nice and user-friendly scheduler in front of him, and then he or she can call in case of problems the SOX scientist that will be on duty, on call, who will call La Silla, interact with La Silla in case of unforeseen transients happening during the night. But the scheduler will also help in this. And here it is. We are also providing to ESO and whatever the scheduler. There has been a talk, a flash talk, and there is also a poster by Laura Squini, who is somewhere here in the room. So she's basically in charge for this, and is also going on. Why do we need SOX? Of course, because this is also the reason why we are all here. Time domain here. There will be a lot of survey. The Vera Rubin one will be the main key facility for this, but also at towards the wavelengths we all know, the big satellites, experiments, and telescopes that are already in operation and that will be in operations in the next few years. So So the idea is that SOXS will provide the spectra to classify and to physically characterize these transients. As has been said in the first day, the second talk, SOXS will also provide an in-kind dataset contribution to Vera Rubin for machine learning tools training. 5 minutes, thanks a lot, so you should be on time. These are the science cases. Basically, here you see almost everything. We will touch almost all of them. In red, they are the flagship, the key cases. So we are mainly, of course, interested in transient science. And yes, the key point is that thanks to the kind of operations, so with this dynamic schedule, the important thing is that we'll be basically always there with the instrument mounted and with the possibility of doing a quick reaction and dense monitoring of what is needed for science, as dense as needed. So these are the working groups. So you see, we're following different science cases and the key person that will take care of the science exploitation of the data, the proposals, and so on. And we also have, the link is public, it is not a very friendly link, but if you Google for the SOXS web page, it is easy to find, is linked also in our project web page. So we have an exposure time calculator. Here you see again for the efficiency I already showed you before. This is some results from the exposure time calculator you can obtain, for example, for a very faint target. You see here 24.5. You can have imaging performance that are comparable to those of EFOSC. So as I told you, we will also have a good imager. It will be also possible to do science through imaging and photometry, although this is not the main goal for what SOXS has been built. These are also tests thanks to the high efficiency in spite of not having the same telescope above. SOXS in particular in the visible harm that is highly efficient will have the expected performance are to be comparable to those of a shooter. So basically we have for the idea is that we have for a target of R band magnitude 20.5, 21 with 1 hour signal to noise of about 10 for spectroscopy on average. So these are my conclusions. So SOXS will be the new single object wideband spectrograph to be mounted in operations at the entity, and has been the concept and everything is the goal is for transient science, for providing classification and characterizations of transients. It took almost 9 years, including everything. Now we are almost there. So the first light is expected to be in the early 2025, and so to be open to the GTO and for the open ESO time starting from October 2025. And the good thing, as I said is that the schedule is not prepared 6 months or whatever in advance, but will be dynamic, night by night, day by day, in order to be as much flexible as possible for the kind of science we aim at doing. Thanks a lot.
Thanks a lot for a great talk. I'm sure there'll be plenty of questions about SOXS.